Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Karla Loida, Project Lead Quantum Computing Hardware at DLR, the German Aerospace Center. Karla and I talk about DLR's 4-year, €740 million initiative, the quantum prototypes they are building, how non-European companies can participate, and much more. We hope you enjoy this episode. Hello, Karla, and thank you for joining me today.
Thanks for having me. I'm looking forward to our chat.
So who are you and what do you do?
I work for the quantum computing initiative of the German Aerospace Center. So I'm basically in charge of all hardware activities of the initiative. I work on our hardware strategy. I work on initiating new project, which means commissioning industry to build quantum computers for the German Aerospace Center. And when it goes into realization, my team of project managers is taking over. I have a background in quantum computing, which is very helpful. I did my PhD in quantum physics a few years ago, and then it changed in management right away, though, and did IT project management of large projects for a while. And then I had the chance to combine my experience in project management with my expertise in quantum physics at the German Aerospace Center, and I obviously couldn't say no.
And the German Aerospace Center is also known as the DLR, right?
Yes, that's the German short version for Deutsches Zentrum für Luft- und Raumfahrt, which means German Aerospace Center. That's right.
So what is the Quantum Initiative? What are the goals, and why is the German Aerospace Center involved in it as opposed to, I don't know, maybe sort of German government or academic institutions and so on? I'm really curious to hear that.
Well, the Quantum Computing Initiative actually is a large government initiative. So the German Federal Ministry for Economic Affairs and Climate Action has provided the German Aerospace Center with €740 million in funding over a period of 4 years to basically carry out this initiative. So our main objective is to accelerate the development of quantum computing together with partners from industries, and also at the same time expand our own expertise in quantum computing as a large federal research center. So what we do is we commission industry to build quantum computing prototypes for the German Aerospace Center. This includes hardware, software, as well as applications. And we are generating a market having startups, SMEs, and established industry compete. And the contracts are financed by 100%, which is an extraordinary chance for young startups to take part in the quantum race. So we're doing a lot of actual building of quantum computing prototypes, so different hardware platforms and technologies. But at the same time, our researchers are also developing applications in the different research fields German Aerospace Center is interested in, and this we also do in close collaboration with industries.
So we're recording this in 2023. Let's fast forward 5 years from now to 2028. What does success look like? If you are now in 2028, you look back at the last 5 years, what would you consider a success for this program?
Well, I would consider it a success if we have all our different platforms that we are commissioning now and the projects are starting about now. If we have all these up and running and can make calculations on all different platforms, compare the results, maybe do some networking in between, be in control of the errors of these platforms. I mean, all of these kind of hardware challenges you may have there. But what we also want to look back to is to the actual establishment of a German quantum computing ecosystem. So right now we have established 2 innovation centers, one in the north and one in the south of Germany. And on these campuses, we provide our industrial partners with offices, lab space, clean room access. So what we want is that on these campuses, we have an ecosystem developed by bringing together our industrial partners, our researchers, and our initiatives. And this is what I definitely want to see when I look back, that this has been successful, that the companies are still around, and that a lot of other activities are happening in the ecosystem that possibly we didn't even initiate, but just happened.
I think you're building or you're funding the build of several different modalities of quantum computers. Maybe you could tell us what modalities you're interested in and maybe what modalities you chose not to invest in at this stage.
Yes. Well, we're actually investing in many different types of quantum computing platforms. We're really open to the technologies, and we just want to expand our expertise and see what platform is working best. So when it comes to full stack systems, we have already started a number of projects, which includes the development of quantum computing prototypes based on ions, photons, diamonds, neutral atoms, and spin-based systems are going to start soon as well. So this is just like looking at different kinds of technologies, but at the same time, all our different projects, they have a little bit of a different focus. Like, for example, for the ion trap systems, we do 3 different types of systems. We're doing a demonstrator because we want to have something to use as quickly as possible, have a shorter development time, but then we're also doing a larger system which needs more optimizing over a larger time period. And then we're working on networking between different chips. So we are looking at all these different aspects. And when it comes to diamond technologies, for example, we are also investing in enabling technologies. So we have projects on the diamond production or the spin characterization to also accelerate the whole like supporting system of industries and the suppliers. So that's the setting we're working in.
Quantum computing is mentioned to have a potential impact on so many different applications, from machine learning to optimization to material design. People are doing computational fluid dynamics with it, and so on and so on. Is there a particular application or a particular set of applications that you're interested in, or really a very broad swath of applications?
Well, we're looking at a very broad range of applications. However, what you should keep in mind is that the German Aerospace Center has some research fields of interest, right? I mean, we obviously work on space and aeronautics, but also on transport or energy or security topics. So these are topics the German Aerospace Center is interested in general. And our researchers, we have 55 different research institutes. So it's a very broad range, and they come up with very nice ideas on what you can work on. And some examples of like application projects our researchers are doing right now is, for example, the optimization of satellite operation planning. That's something from the space sector we are doing. Or when it comes to material science, there is a project on battery simulations, which is also very interesting. And then we have another institute working on atmospheric physics, and they're working on the improvement of climate models with quantum machine learning. So that's just a few examples. And then we also have a few institutes which work really close to the quantum computing hardware, are really working on hardware, software, co-design and cooperation with industries to see how can we really optimize or compile a particular algorithm on a particular hardware, which we actually have in-house. So they sometimes really working with the hardware researchers and like talking about particular qubits and how you could improve them to make the algorithm work better. So there's a lot of collaboration going on there. And but we have all different kinds of applications we're interested in.
I wanted to ask you about the German versus European versus global network. And what I mean by that is Germany certainly has fantastic quantum computing resources, but there are other companies outside Germany that also do wonderful work. Is participation in the program limited to German or to European companies, or is it really open to anyone that can provide a good solution?
Well, our procurements that we do are actually Europe is Europe-wide tender law. So anyone can participate in the procurement, but you have to comply to European law, which is basically the basis. So that's the formal setting. But I mean, everyone is invited to participate and compete. However, we have requirements that need to be fulfilled that include, for example, the participation in our innovation centers, which are located in Germany, because we want to build something there locally and have an exchange there, not only online, but really companies like being in the same building, having coffee together, coming up with new ideas on how to exchange. So that's quite built quite locally, but it's open to anyone who is ambitious enough to compete.
You've been doing this for some time, I believe. What is the thing that has most surprised you as you were reviewing the bids, as you were interacting with companies and choosing the winners?
Well, that's a good question. I think what I found quite surprising is that depending on the different technologies, the field of companies is very different. Like for some technologies, you only see very, very small startups, only just leaving university and starting from scratch. And then for other technologies, you have big consortia teaming up with suppliers such as big laser companies or semiconductor industry. And so I think, I found it surprising that this is at very different stages. For some technologies, it's like big industry has really picked it up already. And it's like, we want to participate and we want to make it like commercially ready. And for other technologies, it's really more in the starting, in the beginning, which doesn't mean that it's less valid, I believe. It's just at a different stage. And this I found very interesting to see.
I think there's a pan-European program where different countries are buying different kinds of machines. Maybe France is buying a photonic computer, and maybe Poland is superconducting, and I may be confusing the modalities in the countries. But I think the goal is to then have the ability to benchmark an algorithm on various modalities and give it broad access. For the DLR program, once the computers are up and running, do you plan to put them in some kind of an HPC center and provide access to others for the purpose of comparison?
Yes, I mean we're definitely planning to provide access to others within research corporations, and we're already working on this. We have a big project which is working on the software platform, basically, where we want to include all our quantum computers to give access to others. And we don't only want to start this when they're all up and running. We want to start this with our prototypes already. Like, for example, the first systems that will be delivered are 4-qubit prototypes this spring, actually, for diamond-based technologies. So already these 4-qubit prototypes, we want to put these on the platform and make sure all our researchers can play with them, can learn from them, can carry out first operations, and then in the next step, we will also make it available to external users. But our idea is to do this as soon as possible, such that we can learn from others, and everyone has the chance to take part and experiment, basically.
What would you like to see more of? Is there a particular field, either hardware or software or some other activity that you say, wow, I wish there was more of this type of work happening in the market?
Well, I would hope, or I would wish that there would already be more work on this supply chain, because like what I see now is that there is a lot of work being done on the prototypes, but that's really only single prototypes kind of put together in the lab. And then there is software companies and research institutions working on applications. But I don't really see like the whole supply chain developing, because I mean the companies and the supply chain is there in most fields or for most technologies. I think they're just kind of scared to invest and take the step and really participate in the quantum computing game, because it's usually big companies. They don't get as much funding as small startups may, so they have to come up with their own financial means, and I find that's quite hesitant still.
When you speak with industrial partners, not so much the manufacturers, but people who might be using quantum computers for their work, do you see them primarily looking for access via the cloud, maybe the IBM cloud or the Amazon cloud, or do you think they're primarily looking to own or sort of have an in-house quantum computer?
No, not really. It's the first option. I think most companies are looking for cloud access, although what I observe now is that no one is really looking for cloud access yet. Most companies are looking for help to find out like what can we do with quantum computing, how can we learn quantum computing. I mean, most of the employees in industry are not equipped to work on quantum computers or to understand the algorithms behind it. So I find that most companies are still quite lost. Just looking for help basically. And but I think in the long run, I'm expecting them to look for cloud access. I don't think anyone really needs a in-house quantum computer except large research institutions or HPC centers, or possibly for security related aspects as the military or government institutions. But I don't think that industry is going to have their own quantum computers. It's all going to be cloud-based.
We spoke a lot about computing, and you mentioned a little bit communications, but in quantum, there's obviously quantum communications and quantum security and quantum sensing. Is the program primarily focused on computing, or do you venture into the other aspects of potential quantum use?
Well, yes and no. I mean, our program is definitely focused on quantum computing. So that's what we're using the investments for. However, we definitely like to venture and see where there is interfaces to other topics, and also the DLR Research Center. I mean, we definitely have research institutions interested in security or communication topics, and also sensing. And it's all very interesting, but our initiative itself is focused on the core.
As we get close to the end of our conversation today, I wanted to ask you a hypothetical question. If you could have dinner with one of the quantum greats, dead or alive, who would that person be?
Well, that's a very interesting question. I think actually it would be interesting, and I think they actually are alive. I think it would be really nice to bring together all the guys who invented the first quantum computing algorithms, like Shor, Grover, Deutsch, and Yoja. I think they're actually all alive. I believe so. I'm not sure. So having them all over for a potluck dinner, and like discussing what they thought when they came up with the first algorithm, because that was way before quantum computing was within reach. So I think that would be really, really fun. Yeah, I should do that.
A potluck quantum dinner sounds great. Please include me if you have any room at the table.
Yeah, of course.
How can people get in touch with you or learn about the RFPs or call for action that the DLR is having in this area?
Yeah, important question. Well, they can definitely just contact me. I'm on LinkedIn as everyone else too, but we also have a homepage, which is qci.dlr.de. And we have short descriptions of all our projects there, hardware as well as applications. There's also the contacts of my colleagues in charge of the other topics. So that would be a good place to look.
Fantastic. Karla, thank you so much for joining me today.
You're welcome.